As two OSPF-enabled routers are going through their initialization process and building a neighbor adjacency, they will actually pass through several different, they call them operational states. Now, you can actually see this when you run the command. It's right here, show IP OSPF neighbors. When you run that command, it will show you your neighbors and it will show you which operational state that they are in. Now, most of the time, what we want to see is the full operational state. And what that means is that everything is synchronized, everybody has the same information, and we're ready to route. But to get there, we're going to go through several of these different states. So let's walk through them. These are the states we'll transition through as we are building a neighbor adjacency. We're going to start out in the down state. Now, in the down state, the router has not received any hello packets from any of its neighbors. So it starts sending out hello packets. And as it does, it transitions to the init state. And in the init state right here, at this point, the router has received hello packets from the neighbor. So I've said hello, they've said hello. We've kind of agreed. We have similar timers. There's nothing in our configurations that's going to stop us from forming a neighbor adjacency. So we'll transition to the two-way state. Now, in the two-way state, bidirectional communication is established. So we're now talking to each other. And then on multi-access links, we're going to elect a DR and a BDR. So that's a designated router and a backup designated router. Now that only happens on multi-access links. And a multi-access link is going to be something like an Ethernet connection, where you could have potentially a switch connected to several different routers and they all share direct connection with each other. On something like a wide area network link, normally that's going to be a point-to-point link, not a multi-access link. So we only elect a DR and a BDR in this two-way state if we are on a multi-access link. Okay, once we've done that, we've established two-way communication, we've elected the DR and the BDR if needed, we'll go to the EX start or exchange start state. Now, this is on a point-to-point network. The routers will determine which will initiate the database exchange. Now, in a multi-access network, that goes through the designated router and the backup designated router. So that's where everything will happen there. And we're going to talk about that more in another video. But on a point-to-point link, we're going to determine which one will initiate the database exchange. And the determination is really simplistic. It's whichever one has the highest router ID. That one is going to initiate the database exchange. So we do that, we move to the exchange state. So at this point, the routers exchange the DBD or database description packets. If any additional information is required. So we exchange DBD packets. We look at the database description we got from our neighbor. We look at our link state database. If there's any information that the DBD talked about that we don't have, then we're going to transition to a loading state to try to synchronize that information. If not, everything matches up. We both have the same data in our databases. Then we'll transition to a full state. Now in the loading state, this is what happens if the database description I got from my neighbor didn't match what I have in my link state database. Then I'm going to send out an LSR or more than one. LSRs are link state requests. I'm going to send out link state requests. I'm going to get back link state updates. We're going to exchange all of those until all information is shared between both routers. We both have the exact same information in our link state databases. Now, once we do that, and we know that we've got consistent information, then we're going to process routes using the SPF algorithm. And then the routers are going to transition to a full state. Now, up here, I said we can use the show IP OSPF neighbors, and that will actually show us the state of our connections, of our relationships. They should say full. Honestly, we move through the rest of these states pretty quickly. So if you catch it fast enough, you may get it to say something else. But within just a few seconds, it should transition to a full state. And in the full state, the link state databases are consistent. Everything is fully synchronized. We have processed all of the routes, and our routers are ready to route data. And so our network can take off and operate. Okay, those are the states that we will transition through as we have two OSPF-enabled routers establish a neighbor adjacency and share information. And once we get here to our full state, everything is set, we're fully operational, and our network can begin routing data in a consistent manner.